Hello and welcome to part 2 of this Hagstrom Base 210. You remember this amp? If you've not watched part 1, then give it a watch and you can see what perilous state this amp was in when we opened it. And you can see I've removed the board, and if we look into the chassis there, you can see there's the oil. It's a right mess. So we're going to tidy up this board. We're not going to tidy it up, we're going to restore it. We're going to strip everything off it. I'm going to get rid of all the oil and look at the oil on the back. I think that's oil. I never actually checked whether that was oil or flux, but I'm guessing it's probably oil. Let's have a look. Oh no, it's flux. My days. We're going to have to get that off as well, aren't we? There's a lot, I mean that could be from the factory. There's a lot of flux on there. Hagstrom 210. Right, I've got all the components out and I've just cleaned most of the solder off. But we've still got a lot of work to do with this board yet. You can see the massive amount of flux on there. And you can see on this side we've got all the oil and stuff we've got to clean off. So none of the traces have come off though. I mean, really, it's a really well made board. I'm quite surprised. Not had a single problem with any trace. Right, I'll get on and we'll start cleaning off some flux. Right, we've got the flux off it, almost 99% of it, so it's looking a lot better now. That is much better, as you can see. Now we turn it over, we've cleaned all the oil off. There's a bit of glue around the doofra on there, but we'll leave that. I don't want to be dissolving that, or we'll end up with that off. It's stuck on pretty well. So there we go, all nice and dry, ready to get the components in. Right, we're stripping this chassis down and it's in a bit of a state. As you can see, we go in there, it's been sprayed with oil, just about everything, and it's covered in oil. So have a look at some of the bits that I've taken out. And you can see got oil all over those, on the pots. We just look at those, you can see it. Now everything, this thing is in dreadful shape. Look at the ground here as well. Well, on the mains power there, through that, just that little bit of a hole there, you can see over the top. Dearie me, it's amazing that's even connected. Somebody's added this power cord at some point, I guess. You can see the film of grime from where these tube sockets have been removed, where I've removed those, and the caps as well, you can see there. So yeah, pretty sick. So I've already stripped off the output transformer. I'm going to be taking off the power transformer as well on there. You can see I've stripped most of the front off it there. Let me just turn it over to look inside, and you can see inside there it is just covered in oil. Terrible. That's just holding it. When he turned it round, held it and turned it around, and I'm covered in oil. Terrible. So I'm going to strip this chassis completely down, and working outside today because the sun's out and it's nice and warm. We're going to strip this chassis down and we're going to clean all this oil out of it before we start. But it's looking like all new parts, switches, everything is just, they've sprayed that much oil. It's even the power switch, you think, well, it's not got inside that, but then when you actually take it out, you can see there's oil all over that, and it's all it's got inside, and you just can't use those again. So that's where we are with this at the moment. Just carry on stripping it down, and then when we've got the chassis bare, we'll have another look. Oh, you can see we've cleaned this chassis up now, and we've got rid of all the oil. You can see on there we've cleaned it up. I'll probably do with painting really, but we could just go on forever more with it. So now we've got to build this back up and clean the faceplate as well. You can see that looks a lot better now on there. So one of the problems with this is the caps. Obviously we've got these square holes, not a lot going to go on there, is there? We can't put some normal size caps on. The terminals will be too close to the chassis, which is a bit of a shame. So we need to find another way of fitting some capacitors in this. Now the power transformer obviously goes there, and the output transformer is bolted somewhere there. This board here is the board for the component board. So we have got to find, and I think that was mounted somewhere there. I have to check back on it. Do you know, it's so long I've took this to bits, and it's so long since I drop back on this project with one thing or another. I can't remember quite where that board goes now. I would assume it goes there because the tube sockets, it can't go there further forward because logic dictates, and also there's holes. In fact, I think it actually goes that way because those holes are offset. Look, they're not in the center. So I think it goes there at a glance, and those holes do fit. So I think it goes there. In fact, that all lines up. And do we have a hole there lining up? Yes, we do. Yes, so that goes there then. So you can see now that the space for the caps is very limited with that being there. Now there are a few other problems we need to sort out on this board as well. Sorry, on this amp. And one is, if you remember, that this only goes up to 220 volts. And that's quite significant with UK voltage, because that's an extra 20 volts, and that will equate to a considerable amount of HT, but it will also, more importantly, considerably increase the filament voltage. So we need to do some tests on that, because we may have to apply a resistor in the filament circuit. So there's a lot of thought got to go into putting this amp together. Also a lot of things, for instance, we don't even have a proper ground point. This amp had the most dreadful ground point for the main ground for the earth off the power. So that that's one thing we need to do as well. We need to get a good solid ground point. So we need to plan out where that's going to be. Now the other thing is that here you can see is where the power came in, and the grip cord, and the power went through there to the transformer. I don't like that idea, so I'm going to drill, if I can, I'm going to try and bring that through the back. So that's the thing we're going to use. You can unscrews there, we drill a hole in the chassis, and we tighten it up. There's an additional nut on there. You've seen me use these before. If you watch the channel enough, you'll have seen there. That goes through. We put the nut on there, and then the cable goes through here like that, through there, and it tightens up on the cable there. Right, so the conundrum with this is how do we mount these caps then? So this is what I've come up with. I've got one of these boards, these tag boards, and we're going to mount these capacitors. We've got to raise this board, and I'm going to mount these radial Rubicons, which are 47 microfarad at 500 volts, and I need 4 of these, because if you remember we had 2 can caps of 47 microfarads in each can, so we need 4. So we're going to raise that and put those there. Now to do that, I'll show you how I've done this. I've removed the tags on this side, flattened these tags, flattened these, and then we're just going to connect to these tags here. Someone else actually in the comments messaged me on part 1 and said that they were actually working on one of these, so I'd be interested to know how they mounted the caps. It took me a while to figure out how to do this, and it's not just putting them in, it's putting them in safely. This is a thing, you know, while you're doing all of this, and it's easy, oh, we'll just bodge some caps in there, but you've got to make sure this is safe when you're doing this sort of thing. You know, I'm not an amp designer, and really what I'm doing here is redesigning this thing, and you know, you've got to make sure you leave it safe when you've finished it. Right, so let's just have a look at what we've done so far with this chassis then. So we've blocked up these 2 holes here, and we've had to do that because we're mounting the capacitors on a tag board at the back of there, and with this amp, that being at the back, if someone pulls this chassis out, they've still got it plugged in, they put the fingers in there and boom, they've had a bite. So we've covered those up to make it safer. We just have a look inside it now. What we've done, you can see there's the tag board that we've mounted for the capacitors to go on. We've also mounted this board, we've put some new standoffs there, and that goes on there, and they've drilled the holes off centre, so bit of a pain how this thing's been put together. A lot of problems. We've remounted the power transformer, and we've got new bolts, new washers, star washers there. So we've done that. Let's have a look at this. So this is another small problem that I've come across. So you can see, if we just look, you can see where the output transformer's clearly been mounted, and if I pop that back on there, you see that bolt there. So they've obviously trimmed off the edge of that to make it fit. It's pretty crude how they've done that. So that goes on there, but there's a problem with that. They're not perpendicular from one another. So although that one is turned on its end, turned flat on its end, but I would have thought maybe that would have been better that way. I don't know. They're also a bit close together for me as well. So we're gradually building this up now. If we look in here, we can see this board goes in there, and you can, it's dropping at the moment because they've drilled the holes off centre, but once it's tightened up it should be fine. So this we've got the gland in there for the power cable, that's in there. We still got 1 or 2 hurdles to cross on this amp. So the diodes will also go on this board. We do have a centre tap on the power transformer, so we don't need a bridge. Just a couple of diodes will do it. But we also may need somewhere to mount some dropping resistors for the filaments. As I pointed out earlier in the video, this only runs at 220 volts. So we may find by the time it's got to 240, having dropped an extra 20 volts on the HT, we're probably going to find the filament voltage is going to be a little high, so we might need to address that. We've got the tube sockets to go on there, and they've got very, very tiny, if we just hold that up, it's got very tiny bolts that go in there, so I'm going to drill those out and put M3s in there. They're actually threaded, this chassis is threaded, but they're just too, I don't like those, they're too small. And I've got no star washers that are that tiny, so I'm going to drill them out to M3s. So you can see we've got all this built up now. We've got the power switch on there, got the sockets, tube sockets, got the transformers on there. Now we've got an array of cables here, and we need to find out what all these cables do. If you remember, we never actually run this amp up, and it was so badly wired. I don't really want to guess what these wires were for. I'd sooner work it out for myself. I've got a rough idea where some of these cables go, simply because of where I cut them from, which obviously were factory. So these two here, I do know, are the tap-ins for the power transformer for the primary side. So 220, I'm guessing, and that one is the 130, was it? So we're going to just check and make sure. These two here, you can see on there, I think they are AC, and that is the ground for AC. That's for the secondaries, for the high tension. And then we've got 3 wires here, which I've a feeling are the filaments. This wire, I think, is negative return back to the transformer. That's what I think at the moment. So we're going to we've got some AC here, and we've got the variac, got the current limiter on there just in case we have any shorts. Right, we've made a start of wiring this amp up, and there's been some major changes with this amp. So the first thing is the power transformer has had to be changed. The power transformer that was originally on it, the 230 volt tap-in was open, just couldn't get any voltage through. The 130 tap-in worked fine, but the 230 was just open. So we've found another transformer for it, and I'll show you that in a minute. It's already on there. But this transformer is slightly different to the other one. The HT voltage is probably the same, maybe a nat's less, which is not a bad thing. Let's just go through the differences. There's only a couple of differences. There's no center taps on the filaments, and there's no center tap on the HT. So that means we've had to use a bridge rectifier, which we've set up there. Those diodes you can see. Now, because there's no center tap on the filament winding, we are going to need a virtual center tap, and I'm just going to turn this over now so we can see where we've wired from on the transformer. So we've used one of these Danbury transformers. We've used these before, and I've got about 5 of these, 4 or 5 of them, but the others are all 12.6 volt filament. You can see it here if we just turn it round. But this one's a 6.3. It was the only one that I managed to get in 6.3 when I bought a bulk of these. So we've wired in here with the filament, and you can see we've got the shrink tube in it. Now we've also wired in here with the 240 volts. That's what we're getting off this AC. And I've insulated that, and I've also put some tie wraps around there, and not as pretty as that, but we don't want that coming off. Absolutely, you know, that is above, it's not inside the chassis, so we need to be doubly sure that that isn't going to come away, because that's the last thing we need, is that exposed. So we've wired from there down inside, and if we go back inside now, you can see we've come through here. We've wired onto the bridge rectifier there, and we've got these wires from the filament there. So what we're going to do because we've got one or two other problems with this amp as well. So one of them is this board. Now these are the original mounting holes for this board. But if we put that board on there, and you can see that it bumps into the other one, so excuse that because it's not wired up yet. Now I can turn it round that way because they've drilled the holes off centre, and you can see that they've got the grounds on there. If we put it that way, it fits fine, but then all the preamp components are down in the power supply and the preamp tube is there, so that's not going to work either. So we're going to have to move this board back. Now I originally had this board over here where the caps were, and I couldn't really wire it, I couldn't really put this board in this corner because of the original transformer, but now I've got a different transformer on, it's enabled me to move that over where all the power supply is. So what we're going to do with this is we're just going to move these bolts back this way, more metal work, and we haven't got a deal further to go with that, but we're going to move those back, and the board will probably sit somewhere around there when we've done that, somewhere there, maybe like that, and we can still get at the tube sockets there to wire them up, and then this will be here like so, and then we can put our virtual center tap onto that and then just wire across to the other tube there. So that's just a few problems there to overcome with this amp, but we're getting there with it now slowly. We've got the fuses on the side as well. We've got one for the power, one for the HT. We've already got that one wired up for the HT. We've got a ground here from the rectifier there, and you can see I've taken the bolt out of the socket because we're going to use that bolt, just socket, tube socket bolt, to hold that in there. And I've also cleaned off the paint there because of course we're using that for ground now, so we need that to be a good connection. Well, that's about where I've got to with this. I don't know, we've got the switch in, I think we've got that in, we've got this in, but we're not going to use it. And if we just go back and look at the on top here again, so you can see we've got some wires going on there. So we've got this wire is the center tap for the power output transformer. We've got to make that up, because if you look at that, it's broken. That was broken on there. It looks like someone had broken this one at one time because there's a bolt through it. I'm not sure how we're going to sort that out yet. We need to take off all these old wires. We'll have new ones coming up there, and you can see that will go up there. And again, we have a bit of a problem here with this being exposed on this amp, and has always been exposed on this amp from when it was manufactured. We need all these three terminals, we need to find a way of insulating those so they can't be touched. The problem I have with this amp is it's such a small chassis that, you know, when people are pulling this chassis out and it's a little bit tight going into the box, they're quite likely to grab the transformers to pull it out, and if they've left it plugged in, then they'll get a nasty shock off there. So it's a case of doing it right and not getting a bite. Obviously I wouldn't pull that out with the transformers, and I'd make doubly sure it was unplugged, but not everyone does that, so I have to make sure that, you know, this amp is going to be right before it goes back to the customer, because in years to come, you know, it may change hands, someone else will have it, and you know, we don't want anybody getting electric shock. So these two wires here are the speaker, which will go down into this front panel here. You can see we've got the socket. To excuse the cars, I've got the door open, so that'll go into there, you can see. And again, it's just, and you can see we've no shortage of holes, have we? Because I've had to grommet such a lot, all of these holes, there was so many of them. So you can see the speaker wires here, we've got a hole there, we can drop that straight through, the wire straight through onto that socket there, which we also need to install. And remember, everything that was in this amp was thrown away because it was covered in oil, absolutely. So there's no, the only thing that survived off the front panel is this this voltage selector we managed to clean up, and obviously the knobs, which are actually here, I've got. So they're the only things that survived. Now I have wired this power supply up slightly differently to what it is on the schematic. It's a bit of a, we'll have a look at that in a bit. It's a bit of a strange way they'd wired this power supply, and I didn't really like it, because the way I looked at that, we could well end up with the way it was wired before. We could have well have ended up with more voltage on the screen than there was on the plate of the output tube. So I wasn't mad keen on that, but we're not going to make massive changes, just a few. And the only other changes we are going to make actually on this for now is the inputs. On the input socket, on the jack socket, the grid stoppers are 470k, which is whoppingly high. So we're going to drop those down to I'm going to drop them to 47k on there, because that's much more for guitar. And and there's also no grid leak resistor, so we are going to add a grid leak resistor on there. So, and I'm not quite sure how that's managed to run without a grid leak resistor on there, because generally it makes inputs unstable if you don't have one as a rule, but it has run for years without one. So we've got the filaments wired up now, coming through here from the transformer. We've used this little tag strip thing here, and we've got our virtual center tap on, going to ground there. We've got the wires coming back here, and we've wired up the filaments on this socket as well. Right, we've got the board in eventually. I took some messing about to get that in, but we've got it in the end. So it's in. I've got this capacitor in there now. You can see I've got these tie wrapped up so they're nice and secure. We've got the grounding for those as well over here. You can see the two grounds there. It's not tightened up yet. So now we've got to start looking at wiring this board up, and these two tube sockets. And once we've done that lot, we've got the front panel, we've got the pots to wire up, the jack socket to go on there, we've got speakers to wire up, and of course we've got this transformer. This is probably the next job we've got to look at. So what problems do we have here? Well, very poor connections on there. That one's been broken off, so we've got to try and fix that. This one is much more secure with a bolt through it, and the second problem is we've got to isolate this. So insulate this. We've got to insulate it so it's safe. Got the two speaker wires there to solder off, and we'll bring those through on there. So we need to lose all of these wires. Right, we've wired up this transformer. Just tidying up those wires there. Make sure it looks nice and neat. And you can see we've insulated this and I'll show you what we've used for it. So I've used a piece of this. This is a large piece of shrink tubing, and we've fitted it over there. We've tie wrapped it, and we've tie wrapped it there as well. So, and that has covered it completely. It's made a really good job, and it's on nice and tight. It doesn't look mega pretty, does it? But it's safe. Right, so we're just going to look at this schematic now for this amp, and I've already changed some of this power supply. Some of it just seems a bit odd. So we've got 15k drop-in resistor here, and we've got creating the third power node. Well, I've created two because I've got a 1.5 between those, and I've got the screen connected to one and the center tap connected to the other, so you got one for each. So we've actually got two nodes now. So this will be my third node with the 15k drop-in resistor, 20 microfarad there. We've got a 22 in, and then we're going down here. We've got a drop-in resistor here, and then we've got another drop-in resistor, and then we've got a 20 microfarad capacitor. So it's like we've got two drop-in resistors but only one cap, which doesn't seem to make any sense to me. So I have just put a jumper across that one. So now we've just got node 4. We've got a 15k drop-in resistor there. we go straight through with no resistor. We've got the cap there smoothing, and then onto the plate resistors there. So to me that makes more sense. Right, so I finally got this thing built up, and we've still got a bit to go yet, but basically it's all together as per the schematic, with a few alterations we've made. We've had to wire this tone stack up here, you can see, and what a nightmare that was. It turned out all those components were just wired similar to how I've wired them there, only I've just done that a bit neater. We've got both tube sockets wired up, all the power supplies wired up except for the AC, which I've left for the time being because we need a pilot light for it. You just look at the front, we tilt it back, you can see there. So we've got a new switch on there, we've got jack socket, speaker socket, we've got new pots in there. We've done away with one of the jack sockets for the input, because there's a little point having that on there. There's a hole for the pilot light. We've got this on here, but of course it's not wired up anymore because it's not safe, and we only have one tapping on this transformer. Remember, we had to change the transformer on this. So it is all wired up, but now what we're going to do is I've got a dribble of voltage going through it, and I'm just going to have a test through. You can see the meter there. That's my phone hitting the floor. You can see that meter there, and we are just going to run through this first of all. We've got no tubes in it, obviously. We always do this. If you watch my channel often enough, you'll know that I always run them up on a low voltage. I've got the current limiter on, but although we've got such a low voltage, that's not really an issue really at the moment. So we're coming in from this bridge rectifier here. So if we go to there, start off, you see I've got 58 volts. Just bring that down a bit. You can see these caps are holding charge pretty much because we've got no tubes in there, but we can use what voltage there is there to work his way through. So let's go to the cap. Yep. Need to go to the plates on the tubes, and that is that one there, I do believe. Actually, pins 3 and 8. 3 and 8. 3. Yeah, got voltage on that plate. 5. 6. I think it's 3 and 8. I'll have to check that, you know, on the pin art again. But I think it's that blue wire there. That's my ground that's just come off. So I've got a temporary ground on the power as well. I don't work on anything without a ground. Yeah, that's the plate there. So we've got that. Screen. Yeah, we've got that there on the screen resistor. Second node, just check it there. Yeah, it's there. Right, let's work his way down to the third node. So we've got the triode here going to the output tube. That's the triode plate. Remember, that tube's got 2 pentodes and a triode in there. That triode is being used as the phase inverter. So we've got that there. Power the other side of there, obviously. Yep. That's good. Now then, dropping resistor there, both sides of there, down to the plates here. Yeah, and there. We got that. Yeah. Yes. Yeah. Oops. There. So that's good. Get that. Yeah. Yeah. So all the voltages there. That all looks good. No problems there. So I think the next thing we can do is probably get some tubes in this now and run it up and see. It's just stick a bit more in there, just see what we've got now. 94, 58, 94. Yeah, that's about right, I would think. That's good. There's no issues with the working volts of these capacitors because they're 500 volts working and 450. This won't kick out nearly that much, even without the tubes in. Right, so that's the first part of the testing done. So the next thing is to pop in the tubes and fire it up. Right, we're ready to roll. So got the tubes in. $85 volts on there now, 59 volts on the variac. Put a bit more in. Nine. So we've got 133 now. We've got 90 volts on the variac. All is looking good. Just $169. Oh, we've got some conductance anyway. And we're away, believe it or not. Well, there we go. That speaker socket's a little iffy. That's a new socket as well. Oh dear. It's me doing that, going to ground. Silly boy. Amazingly enough, that works. I was so hit and miss on the schematic with the values and things. You can't read half of it properly. So, but yeah. So far so good. What voltage we got on there? And we've only got 116 volts on the variac. Let's just have a bit of a test round now. Oh, knocked me ground out. Knocked off the ground. Right, let's have a butcher's. 121, 141. Not bad. What we got on there? 120, 140, 146. Now let's just make sure that the plate and screen voltage are correct. In other words, we should have less voltage. Let me just put some big glasses on to get in there. It's a bit so I can see. So we've got 153 on the plate. Let's see what we've got on the screen. Ah, that's perfect, 145. So how they had that power supply wired before, it would have, it's questionable whether you could have ended up with more voltage on the screen than the plate. There's only a 300 ohm resistor which they were using as a choke, or in place of a choke, to be fair. I'm just going to go up a bit more on the variac now. Now we're up to 136 volts. Now the thing with this amp as well is that the customer said he liked the way that it used to sound, although given the condition of it, it probably hadn't run for a lot of years. Now I've wired most of this amp, I've wired up to the schematic, and these coupling caps here were 5 nanofarad. They'd been swapped in the amp. They were only 5 nanofarad. I've got the original hundreds in, so they're a world apart. Also, this coupling cap here in the preamp stage was also 100 nanofarad on the schematic, and all those 100 nanofarad caps for guitar are just like way bassy. So I've put 22 in there, and I may well have to drop these down as well if this thing's really bassy, because obviously the guy's been playing through it having 5 nanofarad in there. Well, that's not going to be half as bassy. On top of that, we've got 200 microfarad. Well, I've had to put 220 in because you can't get 200, so it's got a 220 microfarad bypass capacitor on top of all these 100 nanofarad caps that are in it. So you know, you're expecting this amp to be pretty bassy. Well, then again, it was a bass amp, but obviously it had been, somebody tried to modify it for guitar badly, but anyway, so we may well end up changing those if it's too bassy. Right, so we're at 136 volts. Now this tube, this ECLL 800, I had to do a bit of translating on the tube data sheet, which is written in German. So I actually worked out that this tube is actually 6 watts dissipation per each side of that pentode. So we've actually got 12 watts in total on both sides of the output transformer there, on both as output tubes, because remember there's 2 pentodes in one bottle. So we're probably only getting about 7 or 8 watts out of this amp, 7 watts happen, something like that. But of course we'll get it onto the scope, which will give us some idea of what we're getting out of it. So let's just, enough of me waffling, let's do a bit more testing. So we've got 133 on there. Now if you remember, I removed for this jumper here, and you can see we've got voltage on there, I removed one of those resistors, those drop-in resistors, because it was just pointless. You remember we looked on the schematic, and I think that's paid dividends, because we've got 132 volts on that plate, and we've got about 135 on here. So let's just go up a bit more. So we're at 150 volts on the variac now, and on that plate we've got 145. What have we got on the other plate? 142. So I'm just going to pull that out now. And the seems pretty quiet at the minute, but then remember we're still missing 100 volts on the variac. What we're drawing on there now. Let's have a look. We are drawing 90 milliamps, but that includes the yeah. So we're drawing 90 milliamps, which seems pretty decent. Now the reason I've not put the power cable on, and I've just tacked onto the transformer, just soldered on with a test lead, is because I put this in here and I've got to drill a hole through the cabinet to get the cable through. So if I'd have put the plug on and everything, it means then I've got to take the plug off again, go and drill the hole and things. So I just tacked on for the time being, and we're fine with that. Now I just need to have a bit of a nosy at the bias. We've got 6.22 across that resistor now, because I don't want this to. 6 watts is not a lot, is it? So we could quite easily end up above that. Remember, we've got the same cathode resistor in as we had before, 180 ohms. We've got the same value, but remember we've changed the transformer, although we should have a bit less plate volts. So we might be okay with that. So let's just do a quick 6.22. Let's just do a bit of maths quick just to see what that tube is drawing. Well, it's only drawing 34 milliamps, and that's for both sides. So we're good. I think we're pretty okay there still. So we can go up a bit more now, having gleaned that little bit of information. Let's see where we are now. We've got 212 now on node 1 and 201 on node 2, and that's good. That's how I like it. 200 volts. It's really, I mean, that's flat out. That is really quiet, which is a bonus again, because the guy that owns this is the guy that owned the Selma Little Giant, and if you remember, we made that really quiet because he was using it for recording. 257 on there now. So let's just keep checking this current on this bias. So 8.48 we've got on there now. Divide by 180, so it's now pulling 47 milliamps for both tubes. So we are now getting into a window. So 47 milliamps, I'll just do this roughly. So you've got 257 there, take away 8, 249. 11.3 divided by 2, 5.86. We're on the money with that. 5.86. So we're not far away. That 8 volts I took off, by the way, was the volts drop across the cathode. Just remember, this amp's cathode bias, so you don't take the plate to ground voltage. You take plate to cathode, but you can take plate to ground and deduct the cathode voltage from it. That's the drop across the resistor. So 5.86, and we've got another 40 volts to put on there, so that might be going a bit over. So we need to be careful now, because we don't want to push that tube. One is because it was very expensive and they're hard to get hold of as well. So we've got 215 volts on there now. Let me just get, that's my phone, by the way, that's doing that. It's because I'm using the calculator on it. 275. See what that drop is now. I think we're going to end up changing this resistor, you know. 9.25. $51 milliamps now. I think it's somewhere probably around 29 milliamps. Yes, that's my dog Shaft, otherwise known as Henchman Dregs when he's in that mode. He's keeping guard, the henchman. So 51 milliamps before we were rudely interrupted by Dregs. Yeah, 6.7. So we're going to have to change that resistor. So you have to be careful when you're running amps up like this. It's not to just run them up, because you could quite easily end up exceeding, as we would have done if we'd have just wind that up to 240. We'll be over dissipating that tube. Now that, you know, if that was a common or Garden EL84 or something, then, and it would, you know, we finished up with 13 watts on it, it wouldn't be a massive issue. You know, a couple of those at 13 watts wouldn't be, but this tube we need to be careful. We don't want to be damaging it. But the amp is really quiet, so I'm just itching. I'm gonna have to stick a guitar through it, make sure what it sounds like. So have I made a mistake wiring that up? It appears I have. Yes, very muddy. This filter now doesn't. Very strange. So that just gets bassier when you turn that up. Let's put it on single coil. Just imagine how bassy it would have been if I'd left the 470k grid stoppers in it. My word, that is incredibly bassy. So this filter doesn't work like a tone control. That's the filter fully in, and if we turn the full filter out, we've got so much bass. Well, I think we can work out why they put the 5 nanofarad caps in it, can't we? Remember, I've swapped one of the 100s for 22 already. Yeah. This used to convert your bass into a double bass. In fact, treble bass. Given the fact that this is a really bright guitar, so that's flat out. Doesn't sound very nice. That's very bassy and woolly indeed. So I've got a 33k grid stopper on the first stage, so I think we need to adjust a few components in this, and you can see why they dropped those 100 nanofarads down. So we are lacking a bit of brightness as well. Right, we've got this amp on the scope, and now I have dropped the bias on this, I've increased the bias resistor to 300 ohms, and that's given me about 6 watts. Now if we turn this amp up, you can see we begin to get crossover distortion. We're about 3/4 of the way up there. You can see now we've got quite a bit. But here's the deal. If you go down to the original 180 ohms, and remember we've got less plate voltage than on that previous transformer. I know that from the maths that I did on it. Now we've got no crossover distortion there, and we don't get any till it's pretty much flat out. So they've been over biasing this tube, and if that's a pretty clean signal there now. So we'll just go back to the 300. And you can see we're just getting the crossover distortion there, just beginning to come in on that. Right, I'm just on the handheld camera now. So if we look there, you can see where it says UA max. That is the plate voltage, 300 volts. If we look at what it says NVA max, 6 watts, I know that's dissipation because I've typed in that rather long word, and I can't even pronounce that. I'm not even going to try. We've got 300 volts on the screen as well. You can see below there U2 max, that's the screen, grid 2 there. And if you look where it says 6 watts, if you go back left across that thing where NVA max, when you go to that really long word that ends in tung, which means power, you can see it says 2 there, and that indicates each side of that pentode is 6 watts. We've got 12.92. 12.92 divided by 300, that gives us 43 milliamps. Divide that by 2, take away 5%, and that leaves us 20 milliamps, 20.4 milliamps. So let's check the plate to cathode voltage now, and that is 306 volts. Notice we've gone over that 300 volts. 6.2 watts. We're over at that, only slightly, but we are over. So let's go back to the scope again. So again, we're at 3/4 of the way up. We've got that cooking there, and you can see now the crossover distortion is in there, and it just begins there. So we have got a bit of it. We've got a clean signal there. We still have a bit of crossover distortion. So it's the same old thing again, over biasing the amp to get rid of the crossover distortion. That's clearly what's being done with this amp to get rid of the crossover distortion there. So let's put the 180 ohm back in just for a second, because I'm jumpering these in at the moment, so I'd cut the original 180 out that I'd put in. So let's see where we are now and how much this amp's been. If you look now, you can see that now we've got more signal there, but if we then drop it back to where it's clean on the scope, you can see we've virtually got no crossover distortion. Right, let's just check the bias. So that's 10.88 we've now got across the resistor. Divide by 180 equals, take that 5% off, divide it by 2. We've now got 28.7 milliamps. That's much higher. 301. Now we've got a plate to cathode. Now they're biased at 8.6 watts a side. So again, quite a bit higher. and that does clean off that crossover distortion. So you can see there, that's quite clean at that. And again, if we pop this 300 ohm resistor back in, you can see there we're just starting to get crossover distortion. So I'm sure we could do the same thing as was done on the Wem Westminster, which we've still got to finish off, where they massively overbias the tubes and get rid of all the crossover distortion. But with this amp, that even if I wanted to do that, it wouldn't be advisable, given the fact that these tubes are quite rare. They're hard to get a hold of. I was lucky to get this one, and this one cost £25, and some of the tubes we looked at were 60 quid, so $60, more than $60 in your money in the States, if you're in the States, with the pound against the dollar. So I'm reluctant to put that tube up any higher than 100%. So let's focus on volume now, what we're getting out of this amp with the 300 ohm resistor. So we're looking clean there, and that means no squaring off the top and no crossover distortion, and you just see a bit of that there. First of all, that's what we'll look at. Let's remove the menu. So peak to peak there, we've got 31.2 on there, you can see. So 31.2 with the 300R resistor. So what we're trying to work out is it worth even overbiasing this tube, assuming we decided to do that. Is it worth it? You know, what mileage are we going to get out of overbiasing this tube? So let's just do the maths on that now, and just see what we're getting out of this amp. That's clean, totally clean with no crossover. We're still in Class A at that. So we need to divide that by 2, 15.6, 707. We need to square that. And divide that by 16. 7.6 watts we're getting out of this amp. 7.6 watts. So now let's swap it for the 180 ohm resistor. And now we're getting a whopping 36 out of there, so that's gone up considerably. But look what's happened when we've put that in. Look, we've now squared off at the top. Let's just take off measure. So you can see now we've got no crossover distortion. At that, let's go back to measure. 33.6 now, so we have gained a little bit of power by overbiasing these tubes. 8.8 watts we're now getting out of those now. 8.8. So we've gained about a watt. Right, back on the scope, we've made some changes. So I'll just go through what changes we've actually made. We have changed the 100 nanofarad coupling caps to 10 nanofarad, which is 5 more than was in it originally. Remember, the customer said that he liked the sound of the amp as it was before, so someone had already modded this amp. We've changed the 220 microfarad cathode bypass capacitor on the output tube. That's now 22, and remember we've biased it with the 300 ohm resistor. We've got 6.3 watts of dissipation on each side of that tube. So that's where we are with it. I've had a bit of a play on it. It's still very bassy, but nowhere near as it was before, and it does sound a lot better. When you turn that filter control down to 0, it still gets a bit woolly, but as long as that's turned full up, it's not too bad. But we are lacking a little bit of top end. Now I've got the channel 1 of the scope there. That's on the phase inverter. And very strange how this phase inverter works. One of the things that made me curious to test that was that if I look on the voltage on one side of the phase inverter, I've got 80 volts, and on the other side I've got 255 volts. And it's something to do with that. One side of that tube is sharing the grid with the phase inverter. It's just really strange set out how that tube works. So naturally I'm thinking I better get the scope on it and just see what's actually going on with it. Now what I've got here is channel 1, and on the green, the channel 2, which is the green on there, I've got the actual output that's coming out of the speaker. So if I just bring up if I bring up this one, now this is a bit tricky to get this. If we look at that, so virtually what's coming out that side of the phase inverter is almost as good as what is coming out the speaker. If let's invert channel 1. So if we go into there, it says invert's already on, so there we go. Just take the menu off. So I would say there we've just about got a match with what's near enough what's coming out of the actual speaker. The other side of the transformer there on the secondary of the output transformer is almost same as what's going into it from the phase inverter into the output tube. So that's pretty good. Let's swap it over onto the other side then, that's got much higher voltage, and they look pretty much the same. So we need to invert that back now the other way. Oh sorry, there, that's it. Let's just, and there is a little bit of difference there. There is a slight difference, but only slight, not a massive amount, but there is a slight difference there. So we're not quite getting as much out of that side as, let's just have a look at measurement. Let's turn off channel 2. There we go. So it's bouncing around because I don't think we've got a trigger on there. Trigger menu. Yes indeed we haven't. Channel 1. That wave gen's gone off. There we go. Now that's settled that. So let's go into measure. Menu off. So we're getting 28 volts peak to peak on that side of the phase inverter. 28.4 volts peak to peak. Just write that down. So let's have a look at what we're getting on the other side of the phase inverter then. We're getting more out of that side. Not much more, but we're getting a bit more. And I could put a probe on each side and you know, check them. So there we go, and we got 28.4 again there going on. remove that and then use the other probe that we have here. That's it. Just turn the menu off, sorry, the measurement off. Must have caught that. Caught that with my hand. Right. Go on the other side. Now then, if we put on channel 2 as well. There we go. Just set that right. So you can see we've got one side inverted, so check that position. So they look pretty well matched on there, don't they? Pretty well matched. So I think that's all going good. Quite pleased with that. There's a slight difference, but it's not massive, is it? Let me just turn this a bit straighter. That's it. Slight difference, but it's not massive. So that's all looking good. Or should we say he's a lumberjack and he's okay, or they're okay, referring to both sides of the phase inverter. Is the first stage coming into the that's coming into the tone stack. First stage going into the tone stack. That looks pretty good. I've got 26.27 volts ish coming into there. Now what's going out of that tone stack? Which is there. Not a lot, look. So that tone stack is very lossy indeed, according to that, because that's coming out to the first stage. We've got peak to peak 26 volts, goes through that tone stack and comes out on the wiper of the volume. Is that correct? Yep. Looking at the schematic, you can't see it, but I can. It's coming out on the wiper of the volume. Look at that for loss. So that tone stack is not particularly nice at all in this amp. That's the gain that we've lost coming through there. That's the filter full up, 4.8. Filter down, doesn't seem to make any difference, does it? So that tone stack is dreadful, and it's costing this amp so much. Right, we've got this Hagstrom bass 210 on the 4x12, so we're going to have a bit of a listen. Very bassy, and I've got this guitar in single coil mode at the minute. So if we turn this filter, see it just gets muddy. Now if I flick this into humbucker, now if I put it on the neck pickup, see, that's really basic. Single coil on the neck pickup. The amp's about 3/4 of the way up. If you notice, it does get a little bit brighter as we turn it up, as I should imagine that's the resistance coming off the pot. But still very bassy, again in humbucker. And flat out. Single coil. So very, very bassy amp indeed. As I say, it does get a bit more top on it as it gets turned up. But that's pretty normal with most amps, to be fair. That tone stack, in my opinion, is dreadful, and this amp's losing a lot of gain because of it, as we demonstrated on the oscilloscope. So, but it's wired up how it was on the schematic, so it is what it is really. So what we're going to do now is I'm going to wrap up this video, and I'm going to finish this off. I'm not going to film putting the power cord on it. I still haven't got the pilot light yet, that's being delivered. So when I get the pilot light, I'm just going to do all the mains on it, power, and sort it all out, put it back in its case, and then I'm going to let the customer have a listen to it, and see how he feels about it. And then if he's not happy, then we'll look at changing that tone stack and, well, either altering it or just taking it out completely and putting another one in. And I think if I have it back for part 3, we'll do some more testing on it. So, and I think one of the things we'll do is we'll bypass that tone stack altogether and just see. I mean, we've seen on the scope how much gain we're losing, but just, you know, to actually listen to it, just see what we're losing there. And you know, the amp doesn't sound bad in itself. There's just too much bass and not enough top on it. You know, if the guy's only using this for recording, then, you know, the fact that it's not mega loud is probably ideal, really. But you know, for gigging, this amp is bedroom use, really, given how much gain it's losing. And really, you know, 6 watts in push pull, you know, really we should be seeing, you know, you've got 12 watts there coming out of that tube disc dissipating 12 watts. We probably should be seeing 8 or 9 really there. So, and you know, that's down to more like 7. So there's room for improvement. But if the customer likes it as it is, then that's fine. You know, we'll just leave it as it is. So that'll do it for this one. So thanks for watching. This has been a bit of a long one again. So, you know, let me know if some of these videos are getting a bit long, if you'd rather them be in parts, you know, parts 1, 2 and 3, or whether you'd sooner see it all as one. Obviously this amp had to be in 2 parts because the first part was quite long as well. But let me know in the comments how you feel about that, you know, the length of the videos. And so we'll leave this one here. So thanks for watching. You all take good care, and I'll see you all in another video. Bye bye for now.